Good afternoon, everyone. I'm Abhay from EDS Technologies. First of all, we thank you all for taking your time out and joining our webinar today on how to create robust structures using concept structure portfolio of SIMULIA Abacus. Before I hand it over to our technical expert, Dr. Varun, I would like to give a brief introduction about our company, EDS Technologies. EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and platinum partner to Dassault Systems. We have served more than 2,000 customers and operate in 10 locations across India, with our headquarters being at Bangalore. We also have various strategic partnerships with world leaders like EOS for additive manufacturing requirements, Human Solutions for ergonomic solutions, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with MAC for visual simulation solutions. We also have strategic partnerships with Esri for GIS requirements and with Synopsys for EDA solutions. We have a dedicated sales, support, marketing, and customer satisfaction teams to address customers' PLM business and support requirements. The speaker for today's webinar will be Dr. Varun Sharma. Dr. Varun holds a PhD in mechanical engineering from the University of Kragujevac, where he focused on numerical modeling and engineering optimization as a Marie Curie early stage researcher. He also holds a master's degree in scientific instrumentation from Ernst Ab University of Applied Science in Germany. His expertise in there was advanced materials. His research experience includes positions as a research intern at Tata Steel Netherlands and a research assistant at the University of Leuven and RHI, Austria, under OECD International Mobility Fellowship. Currently, he serves as technical manager at EDS Technologies, providing support to customers in North and East India in the field of modeling and simulation using SIMULIA methodologies. Before I hand over to Varun, I would request the audience, if they have any queries or questions during the course of the webinar, they can drop in the question box or in the chat box. We shall accept all the queries at the end of the session. Over to you.
Okay. Thank you, Abhay. Thank you for the introduction. I welcome everyone for this webinar. So we will try to explain you everything that we can cover in concept engineering. So hopefully, I mean, if you have any questions in between the sessions, you can feel free to drop a message. We will try to answer it once the session is over. Can you track this back? It is coming back to my screen. I don't know why. Shall I close it here? Okay, thanks. So we will start first with the concept structure engineer. Concept engineering is a very basic terms that usually comes in our mind when we start doing drafting, design or modeling. So concept is always the foundation block of everything. It does includes number of steps. If you talk about engineering domain, it does includes geometric equations, set certain properties, and then performing the simulations, and then understand the design explorations. So that's basically the hierarchy which you can see in my screen. So what happened basically, every domain, every particular department is having their own like certain set of criteria. So if you are into design aspect, you need to have a very good proficiency in CAD tools, and if you are into meshings in a deck preparations in pre-processing part, you need to be very strong in meshing, right? Similarly, for simulations and for explorations, you need to have certain set of skills. So concept structure engineer is basically the foundations and the building block of designing and the modeling department. So we try to create a very fundamental, you can say, or sophisticated platform for every individual who are into R&D, and the tool name is called 3D Experience. So this tool can help you to create your foundation block in just one platform. So if you see the picture which I am reflecting now, it is a very simple but a very detailistical overview, where you can see we have first generative shape design, and a very easy design which you can create in any CAD tool. And then we have done the meshing part in our meshing module, and then the simulation part. Simulation does include certain steps, uh, you know, so those things can be done here in scenario role. And finally, you can see the parametric study. So every aspect, every particular department can be done in just one role, and that role name is called 3D experience role. And currently what we are representing is a part of concept engineering. So you will get to know in my subsequent slide. uh, so let's say you have you are working in automotive sector, and you need to create a detailed picture of your let's say four-wheeler, and you need to start with the very beginning step, right? So this is basically the beginning step, and this could be your final step, right, where you can see the mesh model and simulation model. But how you can do that, right? So there are a number of steps which includes like designing, meshing, setup, scenarios, solve, evaluations, right? So this whole process is basically your process integration and optimizations, which is also called as PIDO, right? So what we do basically, first we do the design, which is predominantly done in CATIA, SolidWorks, or maybe any other tool. And then you pass on the design criteria to your second department, which is your pre-processing department, where you can create material connections and meshing, right? And then you pass on the informations to the another department, where they perform the simulations, where they perform the partial differential equations. They try to solve it using certain solver, right? So every department requires certain set of skills. So if you're into CAD department, you need to invest like weeks, right, to prepare the CAD model, uh, and then you need to prepare again certain weeks to prepare the model, to prepare the pre-processing part, and once everything is done, you need to again iterate the model by changing the mesh size, by changing the boundary conditions until you get to certain approximation values, right? So if you try to see the whole picture, the whole PIDO process, you will get to know like every tool require certain set of skill and certain time period, right? And it is not easy for everybody. If I say, anyone like, are you expert in CATIA? You may be expert, but you cannot be expert in ENSA. Maybe you are expert in ENSA as well, but you cannot expert in, LS China. Maybe you are expert in LS China, but you cannot be expert in every tool, right? So it is a very complex, and very dynamic environment where it is difficult for individual person to learn and understand all the tool, right? So what you can do, you can have one tool, for example 3D experience, where everything can be done. So that's the first key aspect I can tell you here. Whether you are in automotive sectors, medical sectors, or NVH sectors, you can start from the beginning, from the foundation block, and everything starting from your designing till iterations, everything can be done in one platform. So it will help you to switch between the same platform. No need to move from one platform, one software to another software, which is basically a hectic and time consuming process. Okay, so just wanted to show you some of the fact here. So for example, if you talk about little bit about the previous history of uh, like modeling and simulations, way back in 2005, the Dassault system started this development process. Obviously it was started in 90s, but the real product that comes in the market was in 2005, where we have like SolidWorks and CATIA kind of tool for designing purpose. You will get, you will feel very good when you get to hear like Rafale was also created in CATIA. surface modeling was, everything was done in CATIA. So it's a very good platform for designing a spec, right? So slowly Dassault Systems start, acquiring different companies, expanding their horizon, and now they have, different varieties of tools, starting from designing till, low frequency, high frequency domain. So every year, company expanded the software development. So in 2008, they have Abacus, a very renowned finite element analysis tool available across the globe, and we are one of them who are using this tool on daily basis. Then we have eyesight, parametric optimizations. Then we have Tosca, non-parametrics, FE-Save, fatigue analysis, electromagnetics, and so on. So it's a very long history of software Dassault is having. Now the point is why I'm showing this slide to all of you. The point is it's not that easy, to have all the tool in one particular department, right? I mean, I'm talking about a little bit about commercial aspect as well. You cannot, have all the tool in one place. Of course, you have it if you have the money, but and at the same time, it is very difficult as well to learn all the tools, right? So what you can do, you can have one platform called 3D Experience, where all the tools in the form of applications can come and you can use them. So the interface is going to be similar. Of course, the solver, the setup, the tech preparation would be difficult, but everything will be under one umbrella. So let's say if you are having currently CATIA requirement, designing requirement, so you can have CATIA. And second requirement you have is like, let's say, optimizations. So you can have Tosca. And third requirement you need is like low frequency, so you can have Opera. So these three tools, CATIA, Tosca, and Opera, can be integrated in one platform. So that's basically a sophisticated integrated platform where you can perform three simulations, three solver, three different software under one umbrella. So that's basically the hierarchy. So from you can, start from basic concept engineering and you can go to computerized based application software. Okay, so how you can enable this efficiencies, right? So just skip this part, just skip this PIDO part where you are investing days, month, even years. Go back to, your traditional way, which is very complex. Now you can neglect that. Now you can say to your, like your superior or your teammates, like, now it's a time for change. It's time for, change from traditional way to modernized way. How different organization across the globe is rapidly changing, so you have to adopt this technology called 3D experience, which is basically a game changer. uh, why I'm saying, because it not only saving your time, but at the same time it enhance your efficiency and your, thinking capability as well. So you can perform, your design feasibility, technical feasibility, modeling and simulation feasibilities, collaboration feasibilities. So these kind of, multiple evaluations and decision making, design making process can be done under one umbrella. So this is the compass we have. So it's basically, you can say, icon or the graphical representations of the 3D experience. And every time we are using these four domains, or you can say four quadrant. So VR is basically representing the virtual reality, and 3D means 3D modeling. I is basically your informations bloglet, and upper one is basically your modeling, design, meshing kind of, compass. So every specific quadrant represents something, and the user interface is also very intellectual way. So you simply click, for example, VR, and you will have a lot of virtual reality applications. Okay, I will give you the demonstration also in the subsequent slide. So let's talk about a little bit in depth about the portfolio. It's the same portfolio like we have, in every software. So under concept structure portfolio, we have technology called ModeSim. So ModeSim is basically the terms that comes from modeling and simulations, and this technology like includes different aspect as well. So you can start with your like agile concept geometry, then you can perform different disciplinary simulations. Disciplinary means like multi-physics simulations, which starts from your basic static test, and then you can slowly increase your horizon, and you can perform highly nonlinear analysis, which does include symmetrical, contact, and material. And then once you're done with linear nonlinear analysis, then you can perform your design explorations, which is basically your parametric and non-parametric evaluation of like your parameters. So where you can perform design of experiments, approximation, optimizations, Monte Carlo simulations, Taguchi method, standard deviations, noise analysis, and some statistical approach as well. And once you're done with that, you can perform your detailed design investigations, where you can use inbuilt template and customized based design to test your feasibility. So these are basically some of the key aspect which I'm telling you right now, but obviously when you jump inside the software, you will get to know the feasibility, the aspect this software can give you. Well, talking about the key technologies that we can offer you in 3D experience is huge. So I'm just taking one example here for, let's say, a composite. So it is a very unique concept to model advanced material. You can take any advanced material, composite, advanced, ceramics, or maybe metallic forms. So these are some of the very highly scientific materials which require a certain level of skill, but the 3D experience design in a way so that you can create your any model in a very subsequent step, right? So I'm considering the composite example, let's say, and it does include certain level of steps, for example, layers and properties. Then you have to go to interfaces and mapping, and then you can perform the simulation and exploration, right? So let's start talking one by one. Okay. And another example you have is automotive sectors, right? So it does include different aspects. uh, Obviously one person can handle and do everything. I'm talking about designing, and but if you talk about simulations, it's a very complex. You need to split the design, you need to split your geometry into small steps. So here is the division, like you have roof assembly, you have rear assembly, you have left body, you have battery packs, you have front assembly, you have firewall. So similar kind of hierarchy or pictorial representations can be created, where you can see the individual performance, right? In the graphical representation form can also be possible once you complete the analysis, right? So let's say you have the different design, and you wanted to see the dynamics motion. What will happen if you place this particular supporting part? Where should I place it? Shall I shift little bit up? Shall I shift little bit down? Right? So this kind of inclined motions can be provided, uh, and it has already inbuilt template which can give you the feasibility to simply switch from existing to the new one, right? Otherwise you have to go back to the designing aspect, and then you have to create the modifications and then come back again, right? But here you can simply apply the motions, and you can check like what would be the best positions, right? So let's take one example. So if you take the upper part, right, and if you try to go back and look little bit in depth, like how the physics, like how the part is look like, and how it will behave if I change from one material to another material. So here is basically your single layer, I'm just taking the stacked shell layer, and if you make it into a multi-layers, how it looks like, right? So this is basically your single layer, and even the single layer informations will be displayed in a tabular form, where you can see the stacking, uh, their respective name, and the materials which you have assigned, and basically all the layer stacking informations. So every individual informations will be reflected here, and you can simultaneously make the connection as well. So usually what happen in standalone softwares, traditional way, where you have to create individual every informations, but here everything can be done in one single shot, right? So when you define the connections, you automatically define in all the parts, in all in that particular specific layer, and once you do that, you can simultaneously create the longitudinal layouts, which is also required depending upon the connections that you have built, right? And another examples, for example, let's say this is your layer, and now you wanted to create mesh. Just click it, and whether it is a tetra or hexa, you can change, and you can switch, and afterwards you can perform your module structure design. Okay, so once you're done with your connections, then you can go to the parametric studies. So parametric studies will reveal first your parameters dimensions in the like tree forms, which will reflect like the positions, distance positions, and the front bow width you can see here, and then you can see the center bow width, and then you can see the pillar positions and roof rail section width. So it has a very like in-depth specification criteria which you can define. And at the same time, I wanted to reflect here, like we do have a templates. So if you wanted to create your roof panel like in a window form, that is also possible, and you can also use it as a traditional window as well, right? And once you select the parameters here, you can simply select them 20, 40, and 10, and then automatically these parameters will go to the optimizations window, where they will perform the like simple design of experiment studies based on design variable, objective function, and constraint. And in that window, you can define your constraint or the parameters, upper limit and lower limit, right? And once you done with your like adjustment, then you can go to the last one, your modules. So now you can see first is your upper part, and then your all the parameters, all the dimensions, pillars, A pillars, B pillars, C pillars, and do you want them like sunroof, or do you want them like a base? So every modules will come into this hierarchy form, and you can select the one which meet your design criteria, and then you can pass on to the further departments. Basically, you are not passing, you are simply switching your module from designing to simulations. So because everything is integrated and collaborative, you do not have to move. So simply save it and open the new tab, right? So this basically one of the example that I'm giving you, right? So if you go back, like from, I will go back to the same slide again. So you can see we start with stacked shell layer, and then we start with the parametric study, and then we perform the topological variability. So these are basically subsequent level of steps. Every time you can perform on your components or on your assembly. Okay, another example that I can give you here. Now you can see in the window the hierarchy automatically it comes, and now you see I have selected the template. Now you can choose the mesh. So automatically we have a very powerful meshing tool, within a fraction of second it will create hexa meshing. And obviously when you're I will switch back. Yeah, so if you see this now, yeah, like this one. So this particular manager, we say it as structure manager. This window will pop up once you have certain kind of things, and then you can click and it will give you number of options, like do you want which options you want. And so once you select, automatically you will have that final model. Okay, so it's a kind of template kind of things. Okay, like this. Okay, and then you will have the feasibility to create meshing. Okay, so once you're done, let's say now I will compare both the model. So first one is your baseline model, and second one is your sunroof variant. So now you can see a crystal clear like picture. So first time is your model, then you have a simulation model. So for designing, we have used the basic CAD tool inbuilt in 3D experience. Okay, basically they are using a CATIA and SolidWorks integrated features, and then we have colorful pictures, which is basically your finite element analysis picture, which is solved with the help of abacus solver. And then finally we have the output in the form of reaction forces. So now you can see the best part is you have not identified the specific nodes here. So once you've done the model, you simply click I want force versus time, you enter it, and it will plot your graph. So but in traditional way, what happen, you have to create a set of elements and nodes, right? And you need to export it to Excel and then apply certain formulas and then change the units and then create it. But here you can do it in a very short span of time. So now you can see this is the reaction force, which is like going till 65, and then gradually the level of forces is decreasing over a period of time. Similarly, if you see the sunroof variant, again everything is same, just the template is different, and same level of force is applied, but the reaction force, which is not they were expecting. So this is not the correct way, this is the right way, right? So here we have used only two template, only two design postulates. In your case, maybe you are working in rubber industries or medical industries. So let's say if you are into rubber industry, you can create different stiffness of rubber, and you can check the reaction forces, right? So if you are into medical domain, you can create your stent, and you can see crimping, expansion kind of phenomena, and in a very good tabular form with graphical representation with the simulation results. Okay, so this is one of the pictures where you can like once you finalize your model, once you see the result, you can go back to your geometry which is not like up to the mark, and then you can simply go to the left hand side window, which is basically in the tree form, which includes your like basic design optimization or topology design optimization criteria, which includes design variable, response variable, objective function, and constraint. And here you can see your parameters. So you can simply just change the parameters here, let's say from 12 to 14, and from 42 to 45, and then 0 to something else, right? And simply enter it. Then what will happen, everything will change, and you will have the change geometry with the change result. So you do not have to go back to the same step again. So it's a very frequent, the algorithms set in 3D experience is very strong, very accurate, very efficient. and time saving process. You do not have to go back and recreate again. Here everything can be done. And now, like you see here, once you're done, you can simply go to the result, right click, and then click, and you will see the your output. So again, one example I wanted to show you here. Let's say this is your design improvement study, and now you can go to the design variable, go to the parametric managers, and here it will ask you the parameters selected, the maximum limit and the minimum limit, and then you can go to the response variable, again the parameter managers, select the the output reaction force, click OK, and then you can define the objective. Basically, we are replicating the basic criteria of optimizations: design variable, objective function, and constraint. So every time their manager will come and you have to select their values and then perform the study. So this is the design of experiment study. Now you can see. So if you change the dimensions of B pillar from -100 to 250, so you can see what will happen. Okay, so we have red spot and green spot. So red spot is basically unfeasible model, and green spot is your feasible model. So once you click, you will have this kind of colorful pictures. Now you can see the displacement and which point comes and how much your maximum sensor reaction force coming. So basically they will create a line, a feasible design feasible line, which is based on your constraint value. So the green one is the best one, blue one is the least best one, and the red one is obsolete one. So you can see, like, you have done like 10-20 experiments, and the best one is somewhere here. Okay, so just with one model you can have a multiple outputs. Now you see we have done in a very short span of time. So same thing you can replicate on your model, but the condition is you should know how to define the boundary conditions. Okay, so I think the examples we have given was a very good example. Now let's little bit talk about the ModeSim workflow, how it works, how you can take the benefit from it. So like I said, ModeSim is basically an integration of modeling and simulations, right? And it does include this compass, which is basically sorry, uh, which is basically a mixture of a different variant, different departments, and it can help you in a number of ways. So you can start first, with your design aspect, which is your foundation, and which is comes under different rules. So under design we have different design applications based on your requirement. So let's say currently you are interested into surface modeling, so we can give you the role, we can give you the applications based on your surface requirement. And if you say I'm interested more into parametric design, then we can give you parametric design applications. Okay, so it is a development and requirement need approach, and according to your need we can customize the workflow. So once you have done the designing aspect, then you can move to the second stage, which is your modeling. Again, in the modeling, we need to understand your basic requirement. Let's say you are interested into linear analysis, so we can give you a linear solver. And if you say Varun, I'm interested in non-linear, then definitely we can give you customized tool with the capability of non-linear analysis, right? And if you say I'm interested into like thermal, explicit solver, so we can also integrate that. But the condition is first you have to make complete pro forma about your requirement, and according to that we can give you. But of course, if you are interested into the whole package, that is also possible. And once you're done with your design modeling, then again for simulation and results, we do have different applications. So two applications now you can see on my screen. One is called mechanical scenario creations, and second one is physics result explorer. So based on your like how in-depth results you want like automatic based, or you want like manual kind of things. So again, considering your needs and your area of interest, the simulate and results can be provided. Some of the things comes as a template, which is basically the basic requirement, and without it it can't be possible to perform mode stream. That will be provided, but other than that we do have certain automatic capabilities, like you have seen in the previous slides, where you can simply define the parameters and automatically your whole scenario will change with outputs. So those things are available as a customized things. And once you're done with your simulation and results, then you can perform parametric design studies. For parametrics, we have two applications. One is your design study, and second one is process composers. And this is the applications we have used in the previous workshop, which I have shown you now, where you can simply change the parameters and it will change the process. So the short form of this role is called MDO, parametric multidisciplinary optimizations tool. And these four are basically the you can say prerequisites of ModSim. So I would request all the stakeholders who are available now, who are listening to this webinar, just try this ModSim approach, and then you will see the positive aspect of it. I mean, obviously we are stick with the traditional way of working style on standalone tool, but just try with this dynamic approach. You can easily collaborate as well. So for example, if you are sitting into a design department and simulation department is somewhere far, you can log in and just transfer your file from one location to another. It's a very simple process. Another examples I can tell you here. These are basically not example, I would say. These are more about takeaways point. I can say specifically, if you wanted to scale the industry process, when we work in industry or R&D sectors, our key criteria is to save the cost, maximize the productivity, make it efficient, time consuming process, and these are some of the basic criteria, right? So I can give you the surety, like 3D experience is one of the tools which can help you to play with your design, and for sure you will have one of the best design in a very short span of time using this 3D experience tool. And obviously once you're done with the design aspect, you need to make certain more studies, experimentally, physically testing, virtual testings, validations, and so on. So compatibility study is one of the things that you can include. We also say that it's one of the reliability study, which can help you to upstream your design process. So that is also extremely important, and it comes under concept engineering structures. And this is one of the key currently in the market trend, how to upstream your design capability. So I can re-emphasize this point again here. And third point, I can say legacy about the design compatibility. This is basically a part of upstream. So again, it is a part of compatibility study. So just try to take the benefits and see how it can help you in a number of ways. Okay. So I think that's it from my side.
So I would like to thank you Varun, for delivering a very informative webinar. I'm confident that it was helpful to our audience as well. I would also like to thank the audience for taking their time out and joining us for this session. If you have any further queries related to the subject matter or any other simulation requirements, you can always connect with us. Can reach out to us at marketing@edstechnologies.com, and we shall revert back to you with all the details. Also, your feedback is valuable for us, which should help us in improving our engagements with you in the future. In this regard, I would request the audience to please fill out the feedback form, which shall pop up once the webinar is closed. So please do keep an eye out for our upcoming seminars and webinars. You can follow us on our social media for the same. Thank you once again for joining us today. See you at the next session.
Thank you, thank you everyone.